So good morning, everybody. Glad that you're here and awake on a beautiful Sunday morning. We'll try to get the buzzwords out of the way very quickly. So cybercrime, APT, threat intelligence, you already have heard all the others, big data, analytics, and so forth. What I'm going to talk about today is kind of the ways that I use Python and folks like me use Python on a daily basis for our other jobs, some of which is data analysis and other sorts of things. So it's a little bit different, I think, than some of the other stuff that has been here. By way of introduction, my background, I went to UT Dallas here, studied statistics, had a degree in math and computer science there with the focus on statistics. I work with a project called the MLSec project for machine learning with security. So think about firewall logs and network logs and so forth, doing analytics with that. But on a daily basis, what do we use Python for? Well, I do incident response. So your server gets broken into, or there's some sort of intrusion on your company's network, and we do that investigation. Or threat intelligence. Threat intelligence you can think of like this. If incident response is investigating when something bad has happened, threat intelligence is trying to go out in advance of that and get as much information on we can on who is doing bad things on networks, what sorts of bad things, how they do them, that sort of stuff. I want to talk about that in a little more detail. The things that I do not do anymore anyway, not since a very, very long time ago, hence all the gray in the beard, is I don't do application securities. People talk about how do I keep my web app secure. There are folks who specialize in that, and they're really good at it, and I'm not one of them. Red teaming or pen testing or however you want to call it, which is kind of similar ideas. Let me, get authorization and then try to break into your network and then tell you what the weaknesses are. Also important, not challenging because the real problem is that all the networks stink, so it's not much of hard work to be able to get in there. So instead, what do we do? Well, today I'm going to talk about kind of three basic tasks, three basic areas that I focus on a daily basis. Investigating malware, tracking bad guys across the internet, and analyzing incidents for trends is where we get a little bit more to some of the statistical stuff. This is not a code-heavy talk. This is kind of a survey, if you will, some explanations of the sorts of things that we do and why Python matters, and optionally, why folks who might be interested in this but don't come from a security background are actually in a really good position to move into this field if that's something that interests you. So when we talk about malware, one of the first things we do when you get, some indication, whether it's from antivirus or logs or something else, that there's some bad piece of code that's going to do something malicious on your system. Well, one of the first things that we do is triage, right? How bad is it? What does it do? What are we looking at? And you do that a few different ways. Python tools are really, really popular for this. I'm going to talk about a few of them in a second, but the idea is you get some kind of a fingerprint, right, like a cryptographic hash or similar, or some other kinds of indicators, and try to compare that to kind of this other huge known universe of malware. Here's a secret. That's really all most antivirus does, and most of them don't do it very well, right? Not that... I still have it on my kid's computer because they're going to, it inevitably saves me a lot of time and trouble within even the first month of installing it. But IOCs are indicators of compromise. So now you go past just what is in that file and what does it do on the system, either how it behaves or what sort of kind of kernel artifacts you can find. What sorts of things does it do? How does it behave? What addresses does it connect to? What sorts of user agents do you see going across the network? Well, as you can imagine, Python is really good for these sorts of things. So a tool that I've written, it's called Maltrieve, goes out and fetches, every time you run it, let's say every 6 hours or however, a bunch of malware currently being served by whatever kind of compromised or malicious infrastructure is out there. So there are these lists. that are constantly updated of watch out for this URL, it's serving a bad Trojan PDF, or it's serving some kind of Trojan application. And so we pull those down and then go store them off for storage and analysis into a tool, maybe something like Viper. So Viper is a tool for storing that malware and doing some kind of basic analysis so you can pull out the samples that are interesting to you and go do something deeper. One of the most popular tools for this is called Cuckoo Sandbox. It's an open source, these are all open source tools that I'm talking about here. It's an open source tool that essentially runs a heavily instrumented Windows virtual machine, so that as you run a piece of malware in it, then it'll come back and tell you, okay, here are the things that it did, so that you can go have a sense of how bad it is and whether maybe it's not malicious at all. And if it is, what sorts of things does it do and can we watch for on our network? This is all dynamic stuff. This doesn't require being able to decompile code back to assembly or anything like that. Effectively, if you kind of know how your computer or how systems work, then at this point you have a good sense of what you're doing with it. Go back real quick. There are other tools for those who want to do that kind of static analysis, where you take a piece of code, you're not running it, you're decompiling it, maybe you're looking at the different sections within it. If you're looking, like, let's say, at a Windows PE file or a Linux ELF file, right? These are the actual executable file formats in these operating systems. And a lot of those tools are written in Python because of the fact that it's such a useful language for somebody who may not have a background in, let's say, computer science or mathematics, but understands their problem domain, and now they have an easier way of being able to pull that apart without having to delve into the guts of something like C or C++ or another kind of systems programming language like that. Okay, so I have this piece of malware. I understand what it's doing. I can go tell my network administrators or whomever to watch out for this. That's all fine and interesting, but more interesting than that, at least for me, is moving beyond kind of those real technical IP addresses and cryptographic hashes and things, because those are easy for the adversaries to change, right? It's very easy to, even in a programmatic fashion, spin up a new VPS to another country, register new domain names, and so those sorts of indicators have a shelf life of about a day or two at tops. Typically, once they've used it for that long, then it's time to move on, because at that point defenses are catching up and watching for those things. Things that are harder for them to change are also harder for us to find and watch. I have a friend who refers to what he calls the pyramid of pain, and he laughs every time I say it. I think of it like a WWE, two pieces of malware enter, one analyst leaves, the pyramid of pain. But as you move up that pyramid, it becomes more difficult for you to track it, and becomes more difficult also for the adversary to change it. So we have what we call TTPs, which are tactics, techniques, and procedures, which the idea is it's how they do what they do. It's really easy to flip a bit in your compiled executable, right? It's really easy to register a new IP address. It's a lot harder to change the way that you go about doing your own workflow, whether your workflow is data analysis or whether your workflow is online fraud, right? So we enumerate infrastructure, we describe the methods, we do a little bit of attribution. Now, attribution is a little bit of a hot topic right now, as anybody who watched the Golden Globes knows, right? A lot of talk about, let's say, was it really North Korea that attacked Sony? Was it really the Russians or the Chinese or this organized crime group or the NSA or whomever that did this? And for the most part, that level of attribution doesn't really matter, because unless you have handcuffs or cruise missiles and the legal ability to use them, then maybe identifying the specific individual doesn't matter. But if you can instead say, okay, this looks like it's activity from this group that we've kind of identified. We don't really know who they are, but we know that they've done this set of intrusions. Now you have an idea of what to look for based on their playbook and how they go about going about their activities. Those sorts of things are important when we talk about attribution. If you can write a Python client that can deal with a REST API, then you are halfway to being able to be a pretty good threat intel analyst. Most of what I deal with Python on a day-to-day, I would say about half of it, maybe more than half, is really just calling somebody's APIs and using the data that comes back so that instead of having to do it manually, now I can just script that across, 1,000 domain addresses and start look for commonalities. What kind of commonalities do I mean? Passive DNS is a little bit different than your usual DNS. Normally you type in a name to whatever client you're using, right? And you get and it resolves to an IP address. Well, that's fine and good, but as we all know, right, those IP addresses can change. So if I look up PyData.org today, it could honestly and legitimately be a different IP address than yesterday or even an hour ago. But what if I want to know what that IP address was an hour ago? Or conversely, what names were actually seen for a given IP address a day ago, or a month ago, or a year ago? Passive DNS just records DNS responses, sticks them into a database, and in most cases, we then aggregate across a bunch of different organizations that kind of contribute data back. It's not recording data about the requester, about the client that asked it. It's literally just recording the DNS response so that then I can say, hey, what IP address did PyData.org have on a certain day? Or what names have ever been seen resolving to this IP address? Now you can pivot on those things, and that's what we talk about enumerating infrastructure. So you get a piece of spam, and in that spam there's a link, and that link actually goes to something malicious. And now I want to have a better idea of what other possible malicious stuff is out there that relates back to this same activity. Passive DNS is one way to do that. The other way is whois data. So you look up the whois record for a domain, just one domain, and you have like your administrative and your organizational and your technical contacts, right? So it says, okay, here's the registrant, here's the contact information, here's the name server for it. We can do two things. One is historical whois. A lot of folks who are engaging in some sort of online fraud or what have you tend to make mistakes. We call it oopsec, right? Instead of opsec, is they make a mistake. And what will happen is this is very, very common. You know how when you register a domain, you can sign up for like one of these privacy services, right? You pay an extra, I don't know, $5 a year or whatever. And if I go do whois lookup on badguy.com, all I see is, privacy protected through GoDaddy or Gandy.net or whichever they used, right? Well, historical whois lets me see the whois records before the current ones. It's really common that they accidentally initially registered it with their real name and address at the beginning. You think, no, they would never be that dumb. Yes. I've worked on a bunch of cases of folks who got new shiny metal bracelets because this was the mistake that they made at first. Or at least that was the break that enabled the folks who do have that legal authority I talked about earlier to go do that. The other thing is reverse whois. So, you've maybe even with a fake email address, this doesn't matter for this technique, you say, here is the person who registered badguy.com, here's the email address used to register it. Now show me all the other domains that this same email address registered. Well, that's super powerful, right? Because unless they have a different email address for every domain, and there are some groups that do that, and there are other things that you can do, but this is the basic idea, then suddenly you have this whole list of 200 domains used to steal your World of Warcraft account or whatever, as an example of one that I've been working on lately because I get irritated at the spam myself. if you can call these APIs, now you can kind of see where something, even that's relatively simple analytically, right? This is almost kindergarten stuff in an analytic sense. You can pivot on these data so that analysts who don't have, 30 years of programming background or what have you, are able to do some of this initially. I'm not going to delve into the details here. The idea is there are markup languages. Unfortunately, Stix is XML, which is terrible. You basically need a PhD in XML to understand it. JSON, so XML is old and busted. JSON's a new hotness. We all know. We'll move on. But you have a number of constructs in this. It's called the Structured Threat Information Expression Language. It's one of these federally funded research corporations. This one's called MITRE. They do a lot of work around security stuff. They're funded mostly through DHS. So it's weird. They're a private corporation, but they get paid through our tax dollars. I don't know. And they love to over-engineer stuff, which is why this isn't just XML. It's this whole gigantic tool chain that is terrible to work with. But they have Python binding, so I stopped caring about all of that stuff. And so what happens is, in your database, let's say, you use their Python binding and say, here, this object is a threat actor, which is kind of the buzzword or jargon just for somebody who's doing something bad, right? This is their TTP. Like I talked about earlier, the methodology, the tactics, techniques, and procedures. These are the indicators or observables. An observable is something that you can actually see on a system or a network. So an IP address or a user agent or a kernel, a named kernel lock, like a mutex, right? And now you store these things and you pivot on them. And this is where you do some of this, and now you have a better database of what you're looking for in terms of your adversaries, of your threat actors. Varus now takes a step back. If Stix is kind of like those crime databases that have reports of the actual incident report and the investigation and how it turned out, Varus is used for things like the national crime reports that the FBI and state agencies put out periodically. So Varus, the vocabulary for event recording and information sharing, something like that, originally developed by folks at Verizon, where I used to work a long time ago before I couldn't take the evilness anymore and left. What it does is it describes this stuff. There's a little bit more to it. The basic idea is you have 4 things. You have an A4 model. So you have actor, attribute, action, and asset. Who did it? What did they affect? How did they do it? And what did they change on it? So did they just make it unavailable? Did they change the integrity of the data on it? Whatever. Now, you can record this, you have enumerations with them. So actor, obviously you can first break it up by external versus internal. Was it somebody who worked there, or was it somebody outside? Okay, if it was somebody outside, what kind of outside somebody was it? Was it an activist? Was it organized crime? This can even be used to record things that happened by accident. So an actor could include a squirrel that took down a power line, that took down a data center, right? Just by recording one incident, it doesn't matter. But now, this is where we get to the... Okay, so first you get the Python binding. This is the only code I'm going to show you this whole time. And this is just to show you that... so a friend of mine worked on this, a colleague and research collaborator and buddy. And the idea was this is a section of code where we took a couple of public reports about alleged, it's supposed to be Chinese espionage activity. Everything's China, or at least that's what some of these companies will tell you anyway. And we started to record the attributes of it. So this is kind of what it looks like in Python code, and now you build a front end or whatever, and now you can enter this stuff, and that's boring and whatever. But now we get to, I have trouble calling it data science. When I was getting my degree in statistics 20 years ago, data science was, I got a degree in statistics and with a minor in CS. That's what they call it now. Anyway, all that aside, the idea was we did multidimensional scaling techniques. So you have all these different dimensions of an incident, right? And you pick out ones that you care about, and then you run an MDS algorithm on it, right? So you can get a sense of how much they cluster by different types. So we had selected a number of different patterns, if you will. So skimmers. So you hear about, you go to your ATM or you go to pay with your credit card at a restaurant, and there's a little bitty extra device on top of where your card gets swiped because somebody has added it. This is what happened to Barnes & Noble a couple years ago, right? Happens to gas stations all the time. You know how they have the little tape across the opening to the gas pump so you can see it hasn't been messed with, but that doesn't really actually help the problem, because you go up and this happens here in Dallas even all the time. There'll be an extra little piece of hardware right on where you swipe your card that when you put in your card and take it back out to read the information, there's another piece of hardware that's also reading it at the same time and either transmitting it back or somebody comes and picks it up later, and boom, this is how a huge amount of credit card fraud happens. Gas stations are terrible for this. There are other pattern types here, right? So misuse, point of sale, loss and theft. Because when you lose, let's say that you have a company laptop, right? It's got a bunch of important internal data, customer data, what have you. It gets lost. That's a security incident in some sense. It's not necessarily an intrusion, but hey, that data is out and available to other people now. It's interesting that all of these patterns, you can kind of see how they flow a little bit, right? This is the axes here are just, because they're just from MDS scaling, they don't reflect a particular human understandable factor, but this is just to see where they cluster together, except for this green line over on the left, and those are the espionage incidents we hear about in the news sometimes, because they do differ a little bit in how they get carried out, how they function. This is from a project that my friend Kevin Thompson and I mentioned, presented on last year at a summit in Austin on digital forensics and incident response. And we did a whole set of analysis using techniques like these from a public data set called the Veris Community Database, where effectively they're analysts and grad students whose professors force them to do this for credit, go and categorize every incident they can find that gets publicly disclosed. So you see in your local newspaper, the local grocery store had an intrusion, it gets published, this is where that shows up. Once we categorize that, we can go do all these other analytics across these thousands of incidents. And that's a place, again, where folks who have significant domain expertise, but not necessarily analytics or not necessarily deep mathematical expertise, can at least get started based on the tool sets that are available. There are a ton of other places that Python gets used in this world, right? Log analysis, as you can imagine, is huge, right? Building web front end. So there are a lot of folks like me, and probably some of you, who just live in the command line all the time, right? And I write, even within the context of command line interfaces, my interfaces tend to be terrible. You run a command, you get some data back into a JSON file or a YAML file or whatever, and I go work with that. That's not the most useful when it comes to making these tools available. The problem is this. There are a lot of folks, including me many years ago, and probably some of you, who write tools for other people to use to do their jobs. I write tools to help me, and people like me, I guess, do my own job better and more effectively. But because of that, not being a UI or UX expert by any stretch of the imagination, our interfaces are terrible. Bootstrap is like the best thing that ever happened, because at least I can just spit out HTML that doesn't look horrific and is workable. One of the other ways Python gets used really heavily is in forensics examinations. So somebody comes, takes your computer, makes a copy of the disk, and goes and looks for every detailed operating system or file artifact they can find. And the folks who do that sort of work also do a lot of work in Python. Let me write a quick script to go enumerate everything in my Windows registry or what have you. Python again becomes useful here because you see in the theme, right? Folks who have domain expertise but not necessarily analytics expertise can do this. Now then, that data can come back out and get used by analysts like us. This is where we the folks in this room, we tend to kind of have some of the same level of expertise and be able to pull out now these better analytics to understand these sorts of things that we're seeing and how we can better protect systems in the future. And then finally, Python is really popular among those offensive red team, white hat folks that I talked about at the beginning, right? So that as you're breaking into systems or you're testing these systems or what have you, then you're writing a Python script to send that exploit code or to automate some task of moving between systems. If this is an area that interests you, maybe it is, you may think to yourself, well, I don't know that much about malware. Doesn't matter. I don't know that much about pen testing. Also doesn't matter. You want to, at some point, pick up maybe a little bit of that because it's, we live in the 21st century, the same way that folks who work in my field need to pick up some data analysis and coding skills. But the idea is that it is far easier for me as a manager or as a senior analyst to take somebody who is a developer and data analyst and teach them what they need to know about InfoSec than it is to take an InfoSec person and teach him how to code. Way easier one way than the other, because reality is the principles behind what we're dealing with are not that complicated. And in reality, if a programmer already knows how to use APIs and already understands how domains and IPs work, then she is halfway already to understanding most of what we're doing in terms of hunting threats across the internet. We're already there. So just because you see folks, because we have this, honestly, we have the same syndrome, so to speak, in the InfoSec world. And for folks like me who kind of straddle both, it gets even worse. So you think, oh, I know this one thing, and everybody else around me knows all this other stuff, including what I know. And the reality is that there are expertise that you have, and that you have, and that you have, and that you have, that maybe we share little bits of it, but there's all these other things that you bring that we don't already have, which is why this is such a rich area for, not just for business, because that's boring, and enterprise security is also the old and busted. Civic society security is the new hotness. Is also that you bring tremendous value in terms of what research modalities and methodologies you could bring there. With that said, I'm happy to take questions, happy to talk about this stuff. I like a little bit of the interactive stuff. I will be around the rest of the day too if there's questions you have later.